Welcome to Vectoring AI, where we take time to explore the fascinating history and future of artificial intelligence. Today, we begin our journey with the dawn of AI, from the 1950s through the 1960s, a decade of bold ideas, breakthrough experiments, and the first signs of both promise and limitation.
It all started in 1950 with the mathematician Alan Turing. In his groundbreaking paper, Computing Machinery and Intelligence, Turing asked the question that still echoes today: can machines think? He proposed a way to test this, now famous as the Turing Test. If a machine's responses are indistinguishable from a human's, could we call it intelligent? This simple but powerful idea set the stage for decades of research.
Just a few years later, in the summer of 1956, a small group of scientists gathered at Dartmouth College. John McCarthy, Marvin Minsky, Claude Shannon, and others met with a bold vision. They believed that every aspect of learning or intelligence could be described precisely enough for a machine to simulate it. At this workshop, the term artificial intelligence was coined. Dartmouth 1956 is often remembered as the official birth of AI, launching a wave of enthusiasm and research.
From that moment, AI researchers pursued two broad paths. The first was symbolic reasoning, also called logic-based AI. In 1956, Alan Turing and Herbert Simon developed the logic theorist, a program that could prove mathematical theorems. Remarkably, it solved 38 out of 52 from Principia Mathematica. This showed that computers could not just calculate, but also reason. Around the same time, John McCarthy created Lisp, a programming language that became central to AI development. Optimism was high, and in 1960, Marvin Minsky famously predicted that within a single generation, the problem of creating artificial intelligence would be solved.
The second path was inspired by the brain itself, neural networks. In 1957, Frank Rosenblatt introduced the Perceptron, an electromechanical device that could learn to recognize patterns. It was hailed in the media as the first machine to think like the human brain. For a while, it seemed as though machines might truly learn. But the excitement cooled in 1969, when Marvin Minsky and Seymour Papert published Perceptrons. They demonstrated that single-layer networks like Rosenblatt's could not solve even basic problems, such as the XOR function. Neural networks would not see major progress again for many years.
Still, the 1960s gave us early glimpses of AI in action. At MIT, Joseph Weizenbaum created ELIZA, a program that could carry on conversations in English by reflecting user input back as questions. Many people were astonished by how lifelike it felt, even though the program understood nothing. Weizenbaum himself became one of the first critics of AI, warning about the ethical dangers of machines imitating human interaction. Meanwhile, at Stanford Research Institute, a robot named Shakey rolled into history. Built in the late 1960s, Shakey combined vision, planning, and movement. It could perceive its environment, understand simple instructions, and navigate to complete tasks. For the first time, AI was not just on paper but embodied in a robot.
And yet by the end of the 1960s, cracks were beginning to show. Many of these programs worked only in narrow, simplified environments. Real-world complexity was overwhelming. In 1966, a U.S. government study known as the ALPAC report concluded that machine translation research had failed to deliver results despite years of investment. Funding was cut and enthusiasm for language-focused AI dwindled. At the same time, researchers struggled with what became known as the combinatorial explosion, the rapid growth of possible choices that made even simple problems unmanageable for computers. AI had promised much, but reality was proving far more difficult.
Looking back, the 1950s and 60s were a decade of daring imagination and first steps. Scientists created the first chatbots, the first reasoning programs, and the first intelligent robots. They believed the problem of intelligence might be solved within a generation, but they also learned just how challenging intelligence really is. These early decades remind us that scientific progress is rarely linear. It is a cycle of ambition, discovery, setbacks, and renewal.
In our next episode of Vectoring AI, we will move into the 1970s, a period when high expectations collided with harsh realities, leading to the first AI winter.
Thanks for tuning in to Vectoring AI. If you enjoyed this episode, don't forget to like, subscribe, and share the channel. Stay with us as we continue exploring the unfolding journey of artificial intelligence.